going to be using the properties and laws of logarithms to solve equations involving logarithms. And the steps here listed will help us out. First thing you want to do is isolate the logs on one side of the equation, and then use those rules of logarithms learned earlier to combine into a single logarithm. So we're going to condense it down to a single log. Rewrite as an exponential. All right, so go from log to exponent form and then solve for x. You have to check your answers on a log problem. Your argument, that number inside, has to be a positive number after you've plugged it in. That doesn't mean that your answer necessarily has to be positive, but when you substitute your answer back into the argument, that argument has to be a positive number. If it's a negative number, then we can't use that as an answer, and you may have no solution. So let's try this example here. It kind of goes step by step through the problem. First thing is isolate the logs on one side, numbers on the other. So I'm going to add 16 to both sides. So I end up with log base 10 of x plus log base 10 of x plus 9 equals positive 1. Step 2, condense the logs on the left into one logarithm. So there's no powers to pull up, and it's a plus sign in between. So this is going to be log base 10. I'm going to go ahead and put the little 10 in there of, and then it's going to be multiplication, x times x plus 9 equals 1. Go ahead and multiply that out. So I'm going to distribute x times x and x times 9. Step C, rewrite as an exponent. So I'm trying to solve for x. I can't move anything more. I need to get rid of the log. So the opposite of log is exponent. Use the base of the log, becomes the base of your exponent. Your power, remember, is always on the other side of a logarithm. So 10 to the 1 equals x squared plus 9x. To solve for x, and that's our last step here, and then check our answer, it's a degree 2 equation, which means I need to set it equal to 0. I'm going to subtract 10 from both sides of the equation. So I've got 0 equals x squared plus 9x minus 10. And then from here, you need to factor it. Now, you've done factoring probably in another algebra class, and you've got your own ways of factoring. You could also use the quadratic formula if you know how to use that, since this is a quadratic equation. The way I factor is this. There's nothing in common that can be pulled out, so they don't all have x's, they don't have a number in common. So with 3 terms, I write down my 2 sets of parentheses, and I'm going to backwards FOIL it. To get the first term, to get x squared, it's x times x. Now I've got to think about what multiplies to negative 10. So something times something has to give me negative 10, but when I add, it has to give me the number in the middle, positive 9. Do the multiplication part first. So 2 numbers that multiply to 10 could be, or negative 10 could be 10 times 1, and then I'm going to put a positive on the 10 and a negative on the 1. Those same 2 numbers then have to add up to positive 9. If they don't, then I have to guess again on the multiplication, maybe 5 and 2, or change my signs, something. In this case, I guessed correctly, so I'm going to put in a plus 10 and a minus 1. If I FOIL this completely out, I can check to make sure that I get x squared plus 9x minus 10 back. From here, you're going to take and break this down into 2 smaller equations. X plus 10 equals 0, x minus 1 equals 0, and then solve for x. So you've made it into a simpler problem. Subtract 10 from both sides, or add 1 to both sides. And it looks like we have two answers, but here's where you have to check your work. So I go back to my original problem, all the way back up here to the top, and I have one answer we thought was -10. But if I plug in -10 right in here, I'm going to be taking log of a negative number, and you can't do that. So -10 is not a possibility. My other answer was +1. Yep, +1. So if I plug in a +1 here, the argument's positive. That's cool. But it also has to work here. 1 + 9 is 10. That's a positive argument. So my only answer is x = 1. The -10 didn't work, not because the number was negative necessarily, but because when I plug it back in to either of these two arguments, it gives me back a negative argument. So -10 + 9 was going to be -1. Can't have a negative argument.